Microsoft Excel now supports Python code, and it's awesome. Technically, it's still in preview, and you can only access it by joining the Beta Insider channel for Excel. But in this video, I'm going to go over some details to show you how it works and some cool examples I came up with myself. This will probably be a long one, so feel free to put the video on a faster speed or look at the timestamps in the description for different chapters if you want to skip around. Now, one important thing to note is they're slowly rolling this feature out even for people in the beta channel, so you might not necessarily get it. Fortunately, one day I checked and it was there, so I'm making this video about it. Anyway, let's take a look, and if you do end up enjoying this video, be sure to give it a thumbs up. To start off, I guess I can show you the first thing that I saw when I got this feature, which is this window popped up in Excel saying try Python in Excel preview. You can see it says that you'll be able to use common Python libraries, and I'll show you exactly which ones in a bit. There's actually a command to show them all. Also, there's no setup required, which is great, and the rest of this is not too interesting. You can read it if you want. However, there is some important fine text at the bottom to notice. It says, while Python in Excel is in public preview, you will be able to use this feature as part of your subscription. After the preview, you will need to purchase an additional license to use it. I find that pretty disappointing, but I guess they do have to host the code in virtual machines, because I didn't mention this before, but all the code is actually ran remotely in a Hyper-V container for security reasons. It does not run on your local machine, which I think is the right move, but that means they have to host all that computing power. However, in another blog post, they do say that after the preview, some functionality will be restricted without a paid license, and they'll give more details later. I hope that at least they allow you to use the standard Python libraries and then maybe all the extra ones as a paid subscription. I think that would be a more reasonable compromise, because even the standard ones are very extensive and useful. Anyway, let's keep going. If we click Show Me How It Works, you can see on the right-hand side there are some examples that I'll show you in a second, but I chose to run the tour, and you can see that it says to add Python formulas to a cell, you enter equals pi, and then you can just hit Tab to activate it. Then within a cell, you use Control-Enter to commit the formula and run it, and just hitting Enter will add a new line. Then it shows you how there are two ways to actually output the data with this little drop-down. You can output the result as a Python object or convert it to Excel values, and again, I'll show you how that works a bit later. Although, unfortunately, when I clicked this little drop-down, like it said, the tour went away, and I couldn't continue it or figure out how to bring it back, so I'll just have to show you all the stuff. So why don't I show you these built-in examples? Now, these all have to do with analyzing data sets. It's a bit complicated, but there's quite a bit more you can do. But why don't we just take a look at this, and then later I can actually show you some more basic examples. The first example is of the describe function in the pandas library, and pandas is a Python library for data analysis. You can see it creates a Python object called sample df, and the df stands for data frame, and it uses this new XL function to add a range of cells to create this pandas data frame object type. Then below, this cell has a formula that runs this describe method on that object, which generates this table. And it does a bunch of analysis like minimum, maximum, standard deviation, stuff like that. The next example creates a scatter plot. So this actually imports a MATLAB library, and then you can see it uses a scatter function, and again, selects a range for what data to use. And I guess you can also set which is the x-axis with this function. There's another example showing something called a correlation matrix. So you can see how various sets of data compares to other sets. And then there's this example of something called a pair plot, which I'm not super familiar with, but looks complicated. And then the final example is doing linear regression, which is just a fancy term for plotting data and fitting a line to it. Now, that's all great if you want to do a bunch of data analysis, but I do want to show you some more basic examples that might be useful for the average person. Then afterwards, for those of you who are more familiar with Python, I can do some more advanced examples and tips like how to put all your imports and functions in one place to easily keep track of them, as well as some info about the virtual machine's Python environment. Now, if you do have access to the Python feature, it will show up in this Formulas tab in the ribbon, and you can actually add code to a cell by just selecting it and clicking the Insert Python button. You don't have to type out equals pi. There's a couple ways to do it. And also, you can see there's other buttons to reset the runtime and view diagnostics, which is basically the console output, not just the actual returned values. And there's initialization, which I'll go over later. That's basically the default imports. All right, on to some actual demonstration, and you should be able to follow along even if you're not familiar with Python. Python is pretty easy to write. For the most basic example, say you just want to add some numbers. You can literally just enter 1 plus 1, and it will return 2. You can also declare a variable like whatever number equals 5, and then you can do actions on it, like whatever number times 100, and it will return 500. And a real way you might use that is if we have a cell with some number, we can reference that with this new XL function and then put the cell location, and it has to go in quotes. And then we can multiply that by 5, and it'll get the result for whatever's in that cell. Of course, with that, you can already do that with Excel, but imagine something more complicated. Those who are familiar with Python might notice that you don't have to put a print statement for the output. It seems to basically just return the most recent value. So if you do use a print statement, though, it actually goes into the diagnostic panel, and that's also where error messages and stuff will go. As another example, maybe you want to manipulate some text. So let's have a cell with a name in it, and then maybe we have this other cell that you want to use to output a message for the person with the name. So in a new Python cell, what we can do is create a variable with the value XL and then that cell location with the name. Then we can create a new string variable, whatever string name, and use the other name variable in this string. So in this case, the code looks like this, and the F in front of the quotation mark just means it's something called an F string, which just lets you put variables within the string, which is what that bracket with the name is. That just says insert the name variable right there. And now if we press Control Enter, you can see that it says, "Hello, Joe, how are you?" So it took that variable, put it into there. I will note that you don't actually have to have a variable for the string at all. You can just put the F string like that. But if you do create a variable as the last part of the code, it seems like that's what it will output. But let's do an example with something even more useful, which is using regex with the Python code, which I don't believe you can do regex with Excel normally. And regex is basically kind of like a scripting language in its own right, and it's used to, I guess you could say, filter or grab out specific patterns from text that you want to get. I'll show you what I mean by that though. So say instead of the previous example we did, we want to do it the other way around. So instead of putting text into a string, we want to get information out of it. But say the information is in all these strings that are weirdly formatted, like username 0 equals Joe123, and there's a whole bunch of these. But say you just want to get the number and the username from each string. How would you do that? Well, I just had GPT-4 write me up a regex expression to get that information with this code and then put it into an array for me. So we can actually use the regex library for Python and put that code in, just change the text variable to the cell that we want to use it with in this sheet, and then boom, it now outputted a pair of cells. And if we change the number to 5, for example, you can see how it updates automatically. And you can just scale it up if you have a bunch of rows, although doing it that way would have it run the code for every single line separately. You'd probably want to adjust it so it runs it on the whole array using a slightly different script, but I'm not going to get into that. For this next segment, I decided to kind of poke around the feature and get a better idea of how it works and show you how you can actually do quite a bit more than just the default built-in examples showed you. Though if you're not familiar with Python, then this section probably won't make any sense, but don't worry about that. First of all, an important thing I can note is the default imports, which you can see by clicking the initialization button in the menu. And you can see that it imports this stuff by default and also sets up some settings for how that XL function works, which remember is how you use the cell data in the Python code. These cannot be changed, but like it says, you can actually create your own imports and functions and put them in their own sheet at the beginning. And it says that it calculates Python formulas in order of rows and then sheets. So you declare stuff at the beginning, it can be used for the rest of it. So that means you do not have to import the libraries within each cell that you use the code. You could do something like this and create one cell at the beginning. You just put it in like the first sheet of the workbook and import the things there before everything else. But notice if you do that, the cell will just show none type. So one tip I came up with to easily see which things you've imported is to use this preview box that you can add. And it creates a string output of the object next to it. And if you then enable word wrap and add some extra blank lines, it makes a very nice vertical list so you can just see what you've already imported at a glance. You can also declare functions all in one place too to make it easier. You can put in the same sheet or a new one, though you can see that it also shows none type for the functions. So what I did was, to the left, I just added a cell with a label of the name of the functions next to them, again, so I could keep track of them more easily at a glance. Now, some of you might be wondering about the Python environment itself, and it turns out that it's running Python 3.9, and I also listed the site packages directory to see a list of potential built-in packages, and there are a ton of them. Not just the standard library ones, but also seems like every package included with Anaconda, which is like a project that packages a lot of data science libraries with Python. However, keep in mind that even if a package is included, it might not actually be useful because of how the code is run in the remote virtual machine. For example, you could import Colorama as a package, which lets you add colored text to the console output, but since there is no console output, there's no point. Another example is the requests library for sending web requests, and it seems like the virtual machines are running the code so it does not allow outgoing web requests, which I definitely think makes sense from a security perspective though. That being said, you still can fetch web data by using Power Query and creating a table with that information and then putting that into Python afterwards. Also here, I had it output some info about the system environment and environment variables, though I'm not sure if any of these are very useful, just kind of interesting, though I did block out some values that seemed like I might not want them shared, like tokens and keys. Now, next up, I have some more stuff I can show you about how different variable types work with this Python feature, and also some cool stuff you can do with if statements that's a little bit more advanced. You should find pretty interesting. I recorded these parts at the computer, so let's head over there and take a look. So here I have a document that I created just to kind of test stuff out and create a few different variable types and see how they work in Excel with Python. So here are the different types on the left and then what it looks like when you create one in a basic sense. On the right, I'll get to this later, but you can see with a string, it just says the string if you create one. And then with the integer also, it'll just say the integer. Whereas with the rest of these, it will show basically the name of it by default if you just have it in the Python object display mode. So the dictionary, you can see this is what it looks like. List. I'll just kind of go through these. This is a 2D list, so a list of lists. It's like an array, complex, tuple, a set, a boolean, a none type, bytes, and then integer. And then over here for each one, you'll notice when you do have this Python object, if you click on a cell, it's got this pop-out thing that lets you create additional cells next to it that has like a little bit of info about it. So the string one just converts that to a string, and that's what I did for all of these. So you can see the pop-out says Python _str, and that's exactly what I did here. And there's the other one, Python type and type name. So I literally just made a cell for each one to show how that appears for each one. And you can see it actually shows up in the formula. You do the cell number and then .python.str. So this is a Excel function. This is not a Python thing in itself. So this is just what each looks like. Nothing too surprising here. And then for the data types Excel values sheet, because over here it's the object for Python object, over here I wanted to see what each one looks like if it was with the Excel output value. So I switched it from Python to Excel for each one, but for string, looks the same. A dictionary, it says unknown, but I guess that's just because it doesn't really know how to display it. Maybe they'll change that in the future. Right now, the list actually will appear as a list. So you put this in the F4 cell, and then if you create a list, it will create a row or a column of anything in that list. Now, if it's a 2D list, it'll do the same thing. So it will create an array. So everything for this formula, this Python formula, is in this H4 cell. It still highlights these. For this complex variable type, it just doesn't show anything. A tuple, it looks basically the same as a list. A set, it says NA. A boolean, it just says true. And for none type, none. And bytes, NA. So you can see if you use the Excel display type, you can do a little bit more with some of these, such as list specifically, and I guess tuple and even boolean. Whereas before, it has this little symbol that it is a Python type. You can also have this thing pop out like a preview, and you can also have it output to a cell with this. Now in this document, I can show you if statements with Python and Excel, which are really useful. It's a lot easier to do than with Excel, and you'll see why. So I have several examples set up here, and the first thing I can show you is just the basics of how Excel outputs a result. So say you just have this, not even a declaration of string, just says hello world, it'll output hello world, just like this. And same as if you have with a string function as hello world, because it, I guess, interprets this as a string by default. And then in this column, you can see I have these X to run boxes, and you'll see how that works. This is basically going to run whatever command is in this column, only if there's an X in here. So you can see how I have this set up. It says test value 1 is Excel C8, which is this, and it's a string. Okay, so whatever is in this cell is test value 1. And then it says if test value 1 equals X, it will say condition passed, and else it'll say condition failed. But you'll notice it does not actually say that, and you'll see why. So I'll put X in here, and it actually outputs none type. And this is even though this actually should have passed. And the reason I figured out is because even if you're using an if statement, it only seems to be able to output something if there's no indent. So it's on the far left. So I changed that here where I basically did output. I created this empty string variable, output equals nothing. And I did the same thing. So if the string of this one is X, and I can change that here, you can see it changes to passed. And that's because I put the final output value here. And that's just a bit of a nuance. And then I did this a bit differently just to show another way you could do it is instead of having the test in the if string right here built in, you could create a test value, kind of like I did before, where the test value is the string, and then you compare the variable to that string. So you can do it however you want. Again, just like in normal Python, that's just an example. And you can see if I change that to an X, it now says passed. And then just as maybe a real life example, I have this function here, which just uses this other function declared that just sees if it can connect to another website. And you can see, unfortunately, the virtual machine does not have access to the internet, which actually is probably a good thing security-wise. All right, now I want to show you something really cool, which is this eval function in Python, which can be really useful. And it allows you to pass in text as code, and you'll see how this can come in handy. So say I have this formula here. This is literally just text here, 1 + 1. It's not being used as a calculation. Excel is not interpreting it as a calculation or anything. It's literally just text. And down here, I have 2 cells with actual Python code. And on the right, I just put what is in here so you can see it when I'm not clicking on it, but that's just text. Anyway, so you can see if I use this Python Excel thing to get the value of B5, just like this, it literally just takes it in as text. So this is a string here. You can see it didn't do the calculation. But if I use Python's eval method and then put it in, this basically says whatever this is, evaluate it as code. So it basically takes this 1 + 1 and tells it that's Python code. So you can see now the result is 2. Now to show you how the evaluations might be useful, I have this example and how you might approach it with Excel versus Python and show why it's a bit easier. So this is a super basic example. So you have some kind of starting number and a choice, and depending on the choice, you want to run an action on it, a different formula, which I have here. So this one is just multiply by 10, and this one multiply by 20. So one way you could do it is an if statement, where basically you run both of these calculations, have their own cell with the results, and then depending on this A, using an if statement, it either catches the value from this result or this result. Another way you could do it, if you didn't want to have to run all the calculations and then refer to the result, is you could have the if statement have the formulas in here, so it doesn't run the formula unless it's the choice you want. But of course, an issue is if these are very, very complicated formulas, that's going to be hard to read. And also with both of these, notice how because of the way an if statement in Excel works, you have the test and then if it's true or false, but you can't have like multiple or more than 2 options. So if you wanted to have 3, then you would have to do a nested if statement. So that would look like this. And in this one, it's basically saying if the choice is A, then look at the first result. If it's not, run this whole other if statement. And then if the choice is B, then look at C11. And if it's not B, which means it's also not A, then say invalid choice. And you can see, okay, that works if there's like 3, but that's going to go exponential and get harder and harder to read. Another probably better approach is to use a VLOOKUP. So you basically have this table of the possible choices, and then next to it, you would say the result and the calculation. So this way, you basically say, look up the choice in this column, and then give me back whatever result I have in this other one. So that's a lot easier, and you can also have basically unlimited number of choices and doesn't get super complicated with nested if statements. I also have this example of like an indirect way of doing it, but I'm actually probably going to not go into that because it's even more complicated. Anyway, let's get to the Python option, which I think is a lot better. So let's look at this one. So here we can expand this and look at the actual code. And first we get the number, which is the 100. And then we literally, in the Python code itself, kind of hard code the test logic. So if C7 is A, and then I have this lower, so it's either capital or lowercase, it doesn't matter. Then we use the eval thing again, and what I did was put the formulas in here as text. So if it's A, then it says run this formula. And remember, num is the C6. So this is kind of like a VLOOKUP in the sense that you can have more and more options and just refer to each one. And it's easier to read because you can have this like nested structure. But the benefit over a VLOOKUP is you don't actually run these formulas unless it's the correct choice. Whereas with the VLOOKUP, you still had to run all of them and just refer to the correct result. Whereas this, you're actually just choosing the function from the beginning based on it. Now over in this one, it's a bit more complicated, but it allows for more variability. So instead of hard coding the tests here as in the if statement itself, I basically kind of did like the VLOOKUP structure where I have the choice here and then the formula it would run over here. And then what I wanted to do was import this array just as a dictionary in Python, which would make it really easy to input this and get this back. But you can see that when you import an array with this Python Excel function, it actually goes into a Panda data frame, which I just figured out. I'm not going to explain why, but you basically have to convert it to a dictionary like this. Not going to get into super more detail on that. And then anyway, once it's a dictionary, it's really easy to get the right-hand column from the left, and you do that by referring to this dictionary variable, which again is the same as this column, and you put in the key, which is the thing on the left, and it'll give you the thing on the right and put it in this formula variable. So basically, in this case, if the choice is A, then this formula variable is number times 10. If it's B, then it's number times 20. And then we do the eval on that formula like we did before. And obviously the benefit of this over this one is you don't have to create a new if statement for every option. You literally just say, look at this range and use that as a dictionary. It's a lot easier as it's set up. And then over here, I just have an example of how you can actually use try except clauses from Python to catch errors. So notice if someone puts A, B, or C, it's going to look it up in this thing here. But if they put in an invalid thing, it's just going to give an error. You can see it actually created errors all over the place, but in this one, you can see it doesn't know what to do with it. So I'll change that back. But you can see here, I did a try except, and this basically says try this, and if you get an error, then do this exception clause. So the end result is if the choice is not in this column, then it just displays this result, error, oh no. And you can see that's exactly what happened. And what's cool about Python exception clauses is you can actually define what happens with different types of exceptions. I'm not going to get into that, but you can be really specific in what error message you're going to display to the user. And one more important thing to mention, which is good, is these Python cells with code in them will actually update these cell values if you move them. So notice here that choice equals C7 because that's where I put it. But if we move that, you can see it automatically updated to C20. So at least even if you do some hard coding of these values, it will still update in the Python code. So that's good to know at least. All right, so hopefully you found this video pretty interesting. Let me know down in the comments if you have any really cool ideas you might want to use this for that I might not have thought of. And also be sure to check down in the comments because someone might have given a really cool use. If you enjoyed this video, again, be sure to give it a big giant thumbs up for the YouTube algorithm. And if you want to subscribe, I try to make videos about twice a week, usually Wednesday and Saturday, so it should be worth it. If you want to keep watching, the next video I'd recommend is where I was talking about what are the Windows N editions you may have not seen before, or maybe you have, and were wondering. I explained that right here. You can just click on. So thanks so much for watching, and I'll see you in the next one.